Compounds of Noble Gases Part 2. Myself Dr. Digna Varghese. We are going to talk about the compounds of noble gases. In this introduction, structure of xenon fluorides. A chemical structure determination includes a chemist specifying the molecular geometry and the electronic structure of the target molecule. Molecular geometry refers to the spatial arrangement of atoms in a molecule and the chemical bonds that hold the atoms together, and can be represented using structural formulae and by molecular models. In determining the structures of chemical compounds, one generally aims to obtain minimally the pattern and multiplicity of bonding between all the atoms in the molecule. When possible, one seeks the three-dimensional spatial coordinates of the atoms in the molecule. Hybridization. In chemistry, hybridization is the concept of mixing of atomic orbitals into new hybrid orbitals suitable for the pairing of electrons to form chemical bonds in valence bond theory. Hybrid orbitals are very useful in the explanation of molecular geometry, atomic bonding properties, etc., and are symmetrically disposed in space. New hybrid orbitals with different energies, shapes, etc. than the component atomic orbitals. Chemist Linus Pauling was first developed the hybridization theory, which was in 1931, to explain the structure of simple molecules. Here showing some hybridizations: sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, sp3d2 hybridization, and sp3d3 hybridization. The overlaps of atomic orbitals, including the sigma bond, in this only one region overlaps. It's a head-on head region overlap, and in the case of pi bonds there are two regions are overlapping. It's a weak bond, but whereas sigma bond is a strong bond. Here a free rotation is possible. In this case there is no free rotation. It is more stable bond and is less stable when compared to sigma bond. The structure of xenon difluoride. Xenon difluoride is a dense white crystallized solid. It's a powerful fluorinating agent. It's a covalent inorganic fluorides. Xenon difluoride is a stable compound. It decomposes on contact with light or water vapor. It is moisture sensitive. It has low vapor pressure. The geometry is linear. Xenon difluoride synthesis. Xenon directly reacts with the fluorine gas, giving xenon difluoride. And the structure of the compound is: the central element is xenon here, and the atomic number of xenon is 54, and the ground state electronic configuration is krypton 4d10 5s2 5p6. The outer valence shell orbitals are shown here. So 5s2, 5p6 and 5d 0. In the case of xenon difluoride, there are two bonds between xenon and fluorine in a xenon fluoride molecule. Therefore, a xenon atom has two unpaired electrons available for forming two bonds with two fluorine atoms. According to valence bond theory, a covalent bond is formed between two atoms, here xenon and fluorine, by the overlap of half-filled valence atomic orbitals of each atom containing one unpaired electron. This is possible only if one of the 5p electron of xenon is promoted to an empty 5d orbital of the same xenon atom. Energy for initial electron promotion is bonding. Now the excited state for xenon is 5s2, 5p5, 5d1. Now these two half-filled orbitals have a character of possible types of orbitals, but there is a method, that is hybridization, to get an atomic orbital with the proper character for bonding. Therefore, the two half-filled orbitals undergo hybridization and forming a new hybrid orbitals. In this case, sp3d hybrid orbitals are forming, that is, the s orbitals and 3 p orbitals and 1 d orbitals hybridized to give sp3d hybrid orbitals. These 5 sp3d hybrid orbitals having different energies, shapes than the component atomic orbitals. sp3d orbitals are oriented in space in a trigonal bipyramidal fashion. In this case, this sp3d orbital and this in an equatorial plane and making an angle 120 degree, and the one sp3d orbital is above the plane and one is below the plane and making an angle with the equatorial orbital 90 degree. 3 of the sp3d hybrid orbitals contain electron pairs, but the remaining 2 are half-filled orbitals. In this case, 3 sp3d orbitals containing electron pairs and remaining 2 are half-filled orbitals. The two half-filled sp3d orbitals overlap in a head-on fashion with the half-filled 2p orbital of the fluorine atom, each to form two xenon fluorine sigma bonds, thereby forms a xenon fluoride molecule. In this case, number of lone pairs is 3 and number of bond pairs is 2, and the bond angle FXEF bond angle is 180 degree, and the structure of the molecule is linear. Xenon tetrafluoride is a colorless crystal discovered in 1963 it has a square planar geometry. The molecular formula of xenon tetrafluoride is XeF4. It's a powerful fluorinating agent. It is synthesized from direct combination of xenon and fluorine in excess, giving xenon tetrafluoride. And we know the central element is xenon here. The atomic number of xenon is 54 and the ground state electronic configuration is krypton 4d10 5s2 5p 6, and in this case there are 4 bonds between xenon and fluorine in a XeF4 molecule. Therefore, xenon atom has 4 unpaired electrons available for forming 4 bonds with the 4 fluorine atoms. The excited state configuration for xenon is 5s2 5p 4 5d2, and by hybridization sp3d2 hybrid orbitals are formed, and in this case 1 s orbitals, 3 p orbitals and 2 d orbitals are forming a new sp3d2 hybrid orbitals. In this case, sp3d2 orbitals are oriented in octahedral fashion and 4 orbitals are in a plane, and the other 2, one is above plane and one is below the plane, and making an angle 90 degree. And 2 of the sp3d2 orbitals contain electron pairs, but the remaining 4 are half-filled orbitals. In this case, the sp3d2 hybrid orbitals, 2 of the sp3d2 orbitals contain electron pairs and the other 4 are half-filled. The 4 half-filled sp3d2 orbitals overlap in a head-on fashion with the half-filled 2p orbital of a fluorine atom and forming 4 XeF sigma bonds. Thereby forms XeF4 molecule. In this case, the number of lone pairs is 2 and number of bond pairs is 4 and bond angle is 90 degree. The electronic structure of the molecule is octahedral, but the geometry of the molecule is square planar. Xenon hexafluoride is the strongest fluorinating agent. It's a colorless solid, highest coordination of the 3 binary fluorides of xenon. Formation is exergonic and the compound is stable at normal temperature. Readily sublimes into intense yellow vapors. Structure lacks perfect octahedral symmetry. Xenon hexafluoride, the molecular formula is XeF6 and the synthesis of the compound xenon hexafluoride is by the direct combination of xenon and fluorine in excess. We know in xenon hexafluoride the central element is xenon and the atomic number is 54 and the ground state configuration is 5s2 5p 6 5d0 configuration, and we have to, there are 6 bonds, XeF's bonds in xenon hexafluoride. Then there should be 6 unpaired or electrons available for forming 6 bonds with the 6 fluorine atoms. So the excitation of electrons giving 5s2, 5p3, 5d3, and these orbitals undergo hybridization giving sp3 d3 hybrid orbitals. There are 7 hybrid orbitals. The sp3 d3 hybrid orbitals are oriented in a pentagonal bipyramidal fashion. In this case, the angle between the axial and the equatorial orbitals is 90 degree, and between the 5 lobes are in the pentagonal plane, and these orbitals making an angle 72 degree. One of the sp3d3 orbital contain electron pairs, but the remaining 6 hybrid orbitals are half-filled state, and the 6 half-filled sp3d3 orbitals overlap in a head-on fashion with the 2p orbital of fluorine atom each to form 6 XEF sigma bonds, thereby forms XEF6 molecules. Here, the monomeric XEF6 in the gas phase has a distorted octahedral geometry with the lone pair in a trigonal phase. Number of lone pairs is 1 and number of bond pairs is 6. The bond angle is 90 degree and the geometry of the molecule is distorted octahedral structure. This molecule lacks perfect octahedral structure due to this distorted molecule is fluxional molecule. Fluxional molecules are molecules that undergo dynamics such that some or all of their atoms interchange between symmetry equivalent positions. In this case, the lobes of or the lone pairs, the position of the lone pairs is changing from one trigonal phase into other one. Therefore, this molecule is regarded as fluxional molecule. So it has a distorted octahedral structure. Thank you.